Basically, this ocean powered station or ocean powered pump has three parts. The first, the base, and the space frame. This holds the base rests at the ocean floor at the coastline in the depth of about from 8 to 10 feet. The reason why it is 8 to 10 feet is because we have to compensate the tide, which is 3 and 3.5 to 4 feet. So if it is set as minimum, that means if we have something like 8 feet of water, the tide will take it down to 3 feet more or 4 feet more, so still we'll have 4 feet of water. And in this 4 feet of water, at least half of the portion will sink in, but the rest of the portion of the float will be above the surface of the water. And in high tide it will go here to this level, and again, that will be enough, to compensate that one. This is set at the minimum, a ratio something like 4 feet. And the function of this one is like this one. This is a dual pump. That means when the wave hits and it goes up, air in this section is compressed. Now there are two valves here that I can show you. 1 and 2. There are two one-way valves. When the air comes up, this valve shut down. When this valve shuts down, the only option remaining left is for the air to escape through this valve. And we take the compressed air from here, but air cannot go inside, because if air tries to go inside, then this valve shuts down and it does not allow air to come back into the cylinder. When the float is in the up direction, and when the waves hit, it goes up, air goes out. And in the meanwhile, there are two valves here, one valve here and one valve here. These valves open up at the same time. It is sync with the ocean waves. So this allows air to let in, but does not allow to go out. When the wave passes and the flow drops, this valve closes automatically with the internal pressure, but at the same time the compressed air that has only one option to move through this valve, that is one-way valve. So in that cycle, second cycle, when the wave is sinking, compressed air in the lower portion comes out from this passage. So when the waves hits again, it comes from here, from the top. When the wave hits, when goes down, then we get the compressed air on that part. That means no matter what, whether it's going up with buoyancy or dropping down by gravity, buoyancy, gravity, buoyancy, gravity, all times, we get in every stroke, we get compressed air. We do not make electric power at this point. It is very, very cost-effective way to store energy only by making compressed air by ocean waves. Once the energy is stored inside the compressed air chamber, then we can take that energy, run turbines spike-free with total controlled environment. That's the beauty of it. Even the fishermen can take some logs, bundle them up, and guide them through in railings, and with few pumps they can electrify their villages. It is that simple. No complication, just out of the box approach.